of trig equations today. So it says below shows two ways to solve the system of equations y equals sine of x and y equals 1/2 for the restricted domain. Basically, we want to know where does this equal this, right? They graphed both of them for us. In this first picture here, then we know the wavy line is our function sine, right? And then this is the line y equals 1/2 is what they labeled for us. So again, I'm looking for where does this equal this, or in other words, where they intersect, right? Do you guys see anywhere where that happens?
Yes.
How many places?
Two.
All right, once here and once here. Okay, so super nice that in this equation, in this graph, that the x-axis is labeled for us, right? Because we're able to clearly see where those intersect. Where do they intersect at?
Pi 6 and 1/2.
Pi 6, and I think that's 5 pi 6 right there, right? Okay. All right, on the unit circle, not labeled for us, but we should know all the points that fall on the unit circle. So, we know that R is always what on your circle? 1. Okay, so if R is 1, that would be all the way up here, right? Okay, so you had a y value of 1 to get up there. Well, if y is 1/2, that's why they put it here, only halfway up, right? Okay. Does it intersect our unit circle? Yeah. In 2 places, right? Okay. So I'm trying to figure out where is sine equal to 1/2. Okay, well, we can see that it would happen here, and it happens here. Okay, so remember, we should have our unit circle memorized. I know it's been a minute, so we may or may not remember all of our ratios. But remember, I also showed you guys that little hand trick so that you can remember where things fall. Remember, sine is going to be y over r, so that's number of fingers to the right over 2. Okay? So in this quadrant, in quadrant 1, okay, 1 over 2, number of fingers to the right being 1 over 2 would be if I bent this finger, right? I would have 1 finger to the right. Is that the right spot? Okay, so then here is how many degrees? 30. Or what would that be in radians? Pi 6, right? So this would be at pi 6, which is where we said that first one was, right? And it looks like it also intersects over here in quadrant 2, which would be 5 pi 6. Okay? So in this particular case, because everything was nice and labeled for us, this picture was easy to read, right? And we did have to do a little thinking for this one. But remember, with our graph for sine and cosine and tangent, I did not have you guys memorize the points for pi 6 or pi thirds, right? We only memorized at 0, pi halves, pi, 3 pi halves, and 2 pi, right? So you may not remember, if I just give you the picture, where that falls. So here we have this memorized, or at least we can use that little hand trick to help us figure out where things fall. Here, we're not necessarily going to have points like this memorized, okay? So let's keep that in mind. It says, explain why these examples show that sine of x equals 1/2 had more than one solution. So why did we get 2 answers on these graphs instead of 1 answer? Why did we have 2?
It intersected through it.
Right, it intersected in 2 places, right? Okay, so because the 2 graphs intersect twice at the locations you guys said pi 6 and 5 pi 6, right? Okay. All right, for number 2, it says they want you to do the same thing. They want you to find sine of x equals negative 3 pi halves, or y equals sine of x they want you to graph. And they also want you to graph y equals negative root 3 over 2. So just like they graphed them separately here, they graph sine, they graph this line, you're going to graph sine, and you're going to graph this line. Okay, so they're going to have you draw that here on this graph, okay? And then you're going to draw that over here. So they already drew the circle for you for sine. You would just need to draw the horizontal line at y equals that number. Okay, so I know we all memorized the points for sine, right? So we should know where it starts. Where does sine start at? Okay, and we also memorized at pi halves. What's sine at pi halves? 1. What about at pi? 0. And 3 pi halves? And 2 pi? Okay, so I know that my graph of sine is going to look something like this. All right. Okay, now I'm also supposed to graph a horizontal line at negative root 3 over 2. So I don't necessarily know where that falls. Do you guys know exactly what that would be compared to like negative 1? Do you know if it's bigger or smaller?
It's smaller.
It's smaller? Okay, how much smaller?
Like a little bit.
Just a little bit, right? If you convert it in your calculator, if you don't know, if you put in negative root 3 over 2, what does it give you?
So negative 0.86.
Okay, so pretty close to negative 1, just not quite there. Okay, so I could draw myself a line like somewhere down here, right? Okay, and again, looks like it intersects our graph in how many places? 2, right? Somewhere here and somewhere here. Now, I don't know exactly where negative 0.866 whatever falls, right? So this was an estimate, right? But it's definitely not on a line, right? So am I going to be able to tell where those intersection points are just looking at this graph?
No.
Probably not. Okay, so let's try on the unit circle. See if we can figure it out over there. So on the unit circle, like we said, negative root 3 over 2 is just a little bit less than negative 1, right? So if this is negative 1 down here, then that would be right about here maybe, would be that line. Again, looks like it intersects in 2 places, right? Here and here. Okay, and the ratio we get is negative square root of 3 over 2, right? I want to know where is sine equal to negative square root of 3 over 2. I want to know where they intersect at, right? Okay, so sine, we just said, is number of fingers to the right. So which finger would I bend if I want there to be 3 fingers to the right? Okay, and how many degrees is that? 60, which is what in radians? Pi thirds. Okay, so this would happen at pi thirds, right? That would be in quadrant 1 though, right? If I wanted it to be positive, okay? But we said we're looking in quadrants 3 and 4 because that's where our ratio for sine is negative. Sine's only positive in 1 and 2. So what would be our multiples of pi thirds in those 2 quadrants? 4 pi thirds right here, and 5 pi thirds over here. If we don't remember our unit circle, you might want to brush up on that just a little bit for this, okay? All right, so we did end up with 2 solutions again, right? It is true at 4 pi thirds and at 5 pi thirds. Perfect. All right, so it says which method was easier, or which method were we able to come up with solutions using? The first graph or that second graph? Second, right? So we're going to say the unit circle. Because we should have it memorized, right? We actually knew what to apply there. Unlike this other graph where we don't have all those extras memorized, right? So unit circle because we have it memorized. Okay, So number 4 then says, now that we've decided unit circle is easier, they drew us a unit circle so we could answer number 4. This time they said solve for cosine of x equals 1/2 on 0 to 2 pi. Okay, so it says, how would you draw your line? Well, for sine, we drew horizontal lines, right? Because sine is y over r. Okay, so how am I going to draw a line to represent cosine? Up and down, right? And it is positive 1/2, right, is what they asked for. So I'm going to draw a vertical line at positive 1/2, which would be right about here. Since we said this would be 1, right? R is always 1. So it looks like it would hit here and here. All right, so sine was number of fingers to the right over 2. So cosine is going to be number of fingers to the left over 2. So I'm trying to figure out what is the value of x when I have 1 finger to the left. So what is x? Degrees or radians, either one.
1/3.
Right, pi thirds. Okay, so this one is at pi thirds because it's in quadrant 1. This one is just a multiple of it in quadrant 3 because cosine's, not quadrant 3, quadrant 4, because cosine's positive in quadrant 4, right? So what multiple would that be? Good. All right, so when they asked what kind of line we drew, we decided on a vertical line because cosine is an x value. And we came up with 2 solutions. You guys decided on pi thirds and 5 pi thirds. All right. So then it says, explain why sine of x equals 2 would have no real solutions. Okay, well, we said our unit circle has an r of 1, right? So 2, this one was for sine. 2 would be somewhere up here, or this was also a graph of sine. 2 is up here. Why would I not get any solutions there?
It's out of range.
Right. Our unit circle doesn't reach that high. Our graph does not reach that high. Therefore, they're never going to intersect, right? So we would say 2 will never intersect the unit circle because r equals 1. Okay, so every single time I ask you to solve one of these, I don't want you to have to draw it, okay? But now at least we understand where our solutions are coming from, right? It's wherever it would intersect on the unit circle, okay? So whenever you're coming up with answers, realize we're talking about where it would intersect on the unit circle. So now that we understand the why behind it, let's look at solving some equations. So flip it over onto the back. All right, so my goal here is to get x by itself in this equation. So what should I do first?
Add 1.
Right, because remember, guys, this is just like 3x squared minus 1. So like he said, we're going to add 1. So that'd leave me with 3 tangent of x squared equals 1. What would I do next? Divide by 3. So we'd have tangent of x squared equals 1 over 3. And then what? Take the square root, right? We want to get rid of that square. Okay, now remember, I can also write this as square root of 1 over square root of 3 and its equivalent, right? Okay, so then tangent of x is equal to, what is the square root of 1? 1. Okay, over, is there a square root of 3? A perfect square root? No. Okay, so I'll leave it as square root of 3. Now, but remember, guys, anytime I take the square root of something, I have no way of knowing if it was originally a negative or a positive, right? So when we take the square root, we have to put plus or minus. Okay, only thing here is we don't like to leave a square root in the bottom, right? How do we fix that? How do we rationalize the denominator?
Times the bottom.
All right. So root 3 in top and bottom. So I'm going to end up with tangent of x is equal to plus or minus, right. Okay, so when I ask you, where is tangent of x plus or minus root 3 over 3, we're just trying to figure out at what value does that happen, what degree or what radian does that happen, okay? Well, remember, tangent is going to be your number of fingers to the right over number of fingers to the left if you're using the hand thing. So we knew that it was originally a 1 in the top, right? So which finger am I bending if I want there to just be 1 to the right? 1 to the right. Okay. Yeah. And then over to the left, over the square root of 3, yes. So we'd have square root of 3 over 1. Okay, so that would be, which one, what did you say this would be? Pi thirds, right? Because I'd have one finger here, okay? So pi thirds is where that's true. So I could say it's where x equals pi thirds, okay? And we didn't just say where tangent's positive, right? We said anywhere tangent is. So what would be a multiple of pi thirds in quadrant 2? 2 pi thirds. Okay. I wouldn't want to use 3 pi thirds because that's pi, right? And that would not be the same as this, right? Okay, what about in quadrant 3? 4 pi thirds. And then in quadrant 4, 5 pi thirds. Nice. So these would be the 4 solutions. The reason this one has 4 instead of 2 is why? Plus or minus. All right, we're considering all 4 quadrants, not just the positive or just the negative. Okay, so we said originally it came from 1 over square root of 3, right? Which is the same as square root of 1 over square root of 3, right? Mm-hmm. So we said if I were to bend this finger, we'd have 1 here and 3 here. Okay. So that's where it came from. All right. Okay, number 7. Okay, for number 7, we've got 2 sine squared of x plus 3 cosine of x minus 3. So I'm not going to be able to simplify or solve this if I've got sine and cosine, right? So I'm probably going to want to change that. So I can pull the 2 out and say I'm just looking at this part. According to our basic 8 from last week, is there anything I can rewrite sine squared as that would be in terms of cosine?
Sine minus cosine plus 1.
Cosine, yeah.
Cosine squared.
Well, or 1 minus.
Is that right?
What'd you say? What'd you say? It is sine. What can I rewrite it as? Cosine. Yeah. Because remember, guys, it's sine squared plus cosine squared equals 1 is the identity. So if I wanted to get cosine, I subtract the sine. So it's, I want to get the cosine by itself. So I subtract cosine squared. So I subtract cosine from both sides. So this is equivalent to sine squared. Okay? So 2 times 1 minus cosine squared plus 3 cosine of x minus 3 equals 0. Okay. All right, so now that I've changed it out, I can distribute that 2 back in. When I distribute 2 to that parenthesis, what are we going to get? All right, 2 minus 2 cosine squared, and then we'll still have that plus 3 cosine of x minus 3. All right, any like terms we could combine?
2.
So 2 and negative 3. So I have negative 2 cosine squared plus 3 cosine of x And then that would be minus 1, right? Equals 0. We just took a positive 2 and a negative 3 and put them together. So negative 3 plus 2 is negative 1. Yeah, I just took this and combined. Okay? All right. So now this looks like something I could factor, right? Okay. If you don't want to have to deal with the fact that this is that negative 2 trying to get things to multiply to give me that term in the middle, you could make this 4 terms and factor by grouping, which I think is going to be the easier thing to do here, because then you can just make your parentheses match, right? If I wanted to do that, I could rewrite 3 cosine of x as something that adds to give me 3. So what's something that adds to give me 3? 2 and 1. Okay, so I could write this as negative cosine squared of x plus 2 cosine of x plus 1 cosine of x minus 1. So all I did was take this and write it as 2 plus 1 so that it was 2 separate terms. Okay? And now that I have 4 terms, I'm allowed to factor by grouping. So remember, that's where you put these 2 terms in a group and you put these 2 terms in a group. And we only look at one group at a time. So there was some of this on your assignment from last week. We look at one group at a time. What would you guys say we could factor out of group 1?
Negative 2 cos.
Right. So I'm going to take out a negative 2 cosine. If I take negative 2 cosine out of negative 2 cosine squared, what's left? Cosine. And if I divide positive 2 cosine by negative 2 cosine, I would be left with negative 1. Okay? Which is pretty much what is in this group over here, right? So I don't really want to change my other group. Maybe I just factor out a 1 so that I don't change it. Then it would still be cosine of x minus 1, right? And now this piece and this piece match, right? So I take that piece and I pull it to the front. So I'd have my cosine x minus 1. So I have taken it out of here and here. And then in my other group, I just write my leftovers. So my leftovers would be negative 2 cosine of x and positive 1.
Just to clarify, we can still factor on each other.
Yeah. Okay, so now that I have my 2 factors, guys, how do I solve a factor? Exactly. So I'm just going to take my 2 factors, set them equal to 0. So I'd have cosine of x minus 1 equals 0, and negative 2 cosine of x plus 1 equals 0. Okay? So if I want to solve cosine minus 1, all I have to do is add 1, right? And I'm left with cosine of x equals 1. Okay, so if we're considering on our unit circle where cosine is 1, where does that happen? At 0, 1, or 1, 0. Yes, right here on the x-axis, right? Okay. So she said right here, because this is the point 1, 0, right? And cosine is x over r is always 1, so that would be 1 over 1 right there. Perfect, okay? So this happens at 0 or 2 pi, whichever one you want to say that is, right? Okay. For this one, to solve, we would have to subtract the 1, right? And then divide by negative 2. So we would end up with cosine of x equals what do we get?
Wait, why is x 0?
Because she just
At this point, this is 0 or 2 pi. You could put 2 pi if you want.
Oh.
Because remember, just like over here, we go and we list all the places where that happens. So it happens at 0 or 2 pi, whichever one you want to say it is. Okay, all right, for this one, whenever I solve this one right here, what do we get cosine of x is equal to? 1/2. Okay. All right, so remember that means we're looking for where number of fingers to the left is 1. So that's at pi thirds. Okay. And it is only positive 1/2 here, right? We don't have a negative 1/2. So I'm only going to think about where cosine is positive, which would be quadrant 1. Okay, in quadrant 1, like you guys said, that's at pi thirds. Where else is cosine positive? 4. So what's a multiple of pi thirds in quadrant 4? 5 pi thirds. So this one would be 5 pi thirds. All right. So this will get easier if you'll just kind of go and brush up on your unit circle. I know it's a little bit to think about right now if you've kind of forgotten some of those pieces, but if you'll just brush back up on that, this part down here is not too bad. Once you get to the solving part, it's just where does that land on the unit circle, okay?
Wait, Miss Raymer?
Uh-huh.
We did you like the hand thing?
Uh-huh.
For like cosine 1/2.
Mm-hmm.
How do you know what finger to put down again?
So cosine is number of fingers to the left over 2. So we want, when we do that, to have this number, right, the top number. So we know we're going to put down the finger that would give me 1 finger to the left. So I knew that that would have to be this one, so that I'd only have 1 finger to the left. And remember, this is 0, 30, 45, 60 degrees, or pi thirds in radians. Okay? All right. Number 8 actually is already solved for us, right? They already got that term by itself. Okay, so I just need to figure out where is sine going to be negative root 3 over 2. So I don't have to do any solving. I just need to figure out where that's going to fall. So remember, sine is number of fingers to the right. So which finger do I bend if I want there to be 3 fingers to the right? Okay, which is pi thirds. Okay, but look right here. This is negative root 3 over 2, right? Where is sine negative? All students take classes. Bottom 2, 3 and 4. 3 and 4. All students take classes. So it's positive here because everything's positive. Sine is positive here. It's not positive in these ones. Yeah. Okay. So I'm looking for something that's a multiple of pi thirds in quadrants 3 and 4. 4 pi thirds and, okay.
Wait, why are you only looking for 3 and 4?
Because they said we were looking for where it's negative. Okay. All right. So these are my 2 possibilities, right? Only catch here is they said 2x, not x, right?
Oh, yes.
Everybody see that? Where it says 2x, not just sine of x?
Oh, so it would be
Wait,
2
isn't
pi
cosine,
thirds.
isn't cosine like the x, like sine is y?
Mm-hmm.
Wait,
So I'm saying that 2x is equal to these terms.
Miss Raymer, how do you know?
What do you mean?
I don't know. Like, it's just like.
Remember when we memorized the unit circle, I said you only need to memorize quadrant 1 because every other quadrant is just multiples of quadrant 1. So we narrowed down where we were looking for.
It's the same, just in a different quadrant.
So we knew we were looking for quadrant 3 and 4. So I just need to go back in my memory. What's equivalent to pi thirds in quadrants 3 and 4? So that's why we did 4 pi thirds and 5 pi thirds. So you might need to go back and look at your unit circle to memorize.
Where do we get pi thirds? We got the calculation where it says.
All right, so it said 2x equals 4 pi thirds or 2x equals 5 pi thirds. I don't want 2x, I want x. So how can I get rid of 2?
Divide it.
Divide by 2, which is the same as multiplying by
2.
1/2. Okay. If I divide this by 2, I end up with a fraction and a fraction. So I'm going to have to multiply by 1/2, right? So you might just multiply from 1/2 from the beginning. Either way, that goes away. All right. So whenever I multiply these two fractions, what do I end up with?
2 pi thirds divided by 6.
Because this is going to be 4 pi over 6, which simplifies to 2 pi thirds. And then I got to do the same thing on this one, right? Times 1/2 times 1/2. What do we end up with? 5 pi 6. So these would be our two solutions.
Oh wait, yeah. How do you get pi thirds from square root of 3?
Okay, so right here, square root of 3 over 2. Remember, this is number of fingers to the right because it's sine.
Oh, I get it. And then so you just want to put on your fingers and this is
For sine. For cosine, it would be fingers to the left, but for sine, it's fingers to the right. No. 0, 30, 45, 60, 90. Okay. Yeah, I can get you one in just a second. Let me finish these next 3. Okay. So next one says solving trig equations for no domain restriction. So the ones that we just did this for, guys, we only were supposed to be going from 0 to 2 pi, right? On our unit circle, what happens if you go past 2 pi?
Oh, it just repeats.
It just repeats itself, okay? So I would just need to say my answers would be the same as whatever we would normally come up with, but in repetition, infinitely, right? Because it keeps going forever and ever, okay? So in this particular picture, it says how many solutions are there for 0 to 2 pi? Remember, solutions are the same thing as like x-intercepts. So how many x-intercepts do you have from 0 to 2 pi? 3. All right, we got one here, here, and here. Okay, so we come up with 3 solutions. What are those solutions? 0, Where else?
Pi 4.
Pi and 2 pi. Good. Okay. How many solutions would we be able to come up with if I didn't restrict you to just 0 to 2 pi? Infinite, right? Because it's just going to keep repeating itself over and over and over again, right? Okay, so it says, how could we then write it to express our different answers, like what we did up here, if it's going to go on forever, if it's going to be infinite?
X
Plus or minus.
Plus or minus.
0 and then.
Well, it depends on which one you want to start with. So if you did start with 0, you could do 0 plus or minus. Okay. N. Okay. Or I could have started with pi and said the same thing, right? Or I could have started with 2 pi and said the same thing. So in this particular case, it does occur every pi, okay? But how long is our period?
It's 2 pi.
2 pi. So if I needed to skip any, then I'd have to say plus or minus 2 pi, right? But for us, in this instance, it repeats itself every pi. So I can just use pi. Okay? Why does this work? Why can I say that?
That's what it is. Like, what do you mean?
Why can we write it this way? What did you guys say I could use this for?
Solution every pi.
Okay, perfect.
So smart.
So because I'll say solutions occur every pi over the period 2 pi, right? Okay. All right, so for these, I'm going to let you try them. I'm going to get you started on this first one, okay? And then I'll leave the other 2 to you. But for number 13, I'm supposed to solve, right? So I'm trying to get x by itself, then that means all the x's should be on one side of the equation, right? So what do I need to do to get all the x's on one side of the equation? Yeah, whichever one you want to do. Maybe keep your lead coefficient positive, so maybe you add sine to both sides. All right, so I'd have 1 sine and 1 sine, so that would be 2 sine of x plus root 2 equals 0. Okay, so I'm trying to get the x by itself. I would move the root 2 over. So I have 2 sine of x equals negative root 2. Then what should we do? Divide by 2. So I'll have sine of x is equal to negative root 2 over 2, right? Okay, so remember, this is what I'm looking for on my hand, right? Sine, remember, this is fingers to the right. So which finger do I bend if I want 2 fingers to the right? Middle, okay, which is how many degrees? 45, which is what in radians? Pi force, okay. So it is pi force if it's positive, but did they say they want positive? They want negative, so which quadrants am I looking at? 3 and 4, right? Okay. So here and here. So what are my multiples of pi force in those 2 quadrants?
7 pi force.
7? Wait. Yeah, it's 5.
5 pi force and 7 pi force. Yeah. So if I was only supposed to give 2 answers, those would be it, right? But they said no restriction, right? They said all solutions.
I thought we were doing 3 and 4. Is it 5 pi force?
And 7 pi force.
Seven pi force is 1 2, 3, 4, 5.
Yeah.
So what would it be?
So whenever I go write my answer, I want us to write something like we did here, right? So it doesn't matter which one you pick. You can pick your 5 pi force or your 7 pi force. Maybe we do 5 pi force as the first one, kind of like we picked 0 on the last one. I do 5 pi force, right? Plus or minus, we have to go with what this time? 2 pi. Why do we have to go with 2 pi? Because that's the period, right? We don't want the positives. We only wanted the negatives. And if we would have just done pi, it's going to hit them all, positives and negatives, right? Because up here, we didn't care where it hit. Here, we don't want those other quadrants. So we do have to pick 2 pi instead of pi. All right?